This video is sponsored by DevMountain. If you're interested in learning web development, iOS, or UX design, DevMountain is a 12-week design and development bootcamp intended to get you a full-time position in the industry. To learn more, visit devmountain.com or click the link in the description below. Hey, what's going on, guys? So I've recently had quite a few requests to do some videos on things like algorithms and data structures and coding challenges and stuff like that, deeper programming principles rather than the standard, practical projects that we build and crash courses. So I want to get into that, and you guys can let me know what you think about that idea. So in this video, I want to take a look at a specific data structure called a linked list. And linked lists, you can create with any language. We're going to be using JavaScript. We're going to create a linked list class so that we can add some methods to read from it, add to it, remove from it, and so on. Now, before we jump in, I just want to kind of explain what a linked list is for those of you that don't know what it is, or maybe just have heard it before but don't really understand what it is. So basically, it's a linear data structure, and I have down here an image of what a linked list looks like, I guess, physically. And this diagram here really helps me out. Helped me out to understand how it works. Now, and I'm going to keep this open throughout the whole project or throughout the whole tutorial. So it's a linear data structure. It's an ordered collection of data. But unlike something like an array, the elements or the nodes in a linked list, they're not stored in sequential memory locations. Instead, the elements are linked together using a pointer. Okay, so basically we have here different nodes or different elements within the linked list. And the first node is called the head. And basically the head, or I should say each node has two things. It has the actual data. In this case, we're just using numbers. And then it has a pointer or a reference to the next element in the linked list. Okay, so you can see that this one has 100 for data, and then it has a reference to the next element, which has 200 as its data. Then it has a reference to this one has a reference to this one, and then this last element or node in the linked list is known as the tail, and the tail is going to have a reference to null. Okay, so that's how you know that it's the end of the list. So they're quite literally linked together. And what's going to happen is we'll have a class, and the only property in our linked list class is going to be the head, because everything stems from there. All right, so I mean, if you want to read more about it and look deeper into it, there's some great information on the internet, articles and stuff like that. But we're just going to create like I said, a class, a couple classes. We're actually going to have a class for a specific node and then have a linked list class. But before I do that, let's just do a very, very simple example. So if I say we have a node and it has the data of, let's say, 100, and then we have node 2, and let's say that has data of 200. So these are two completely separate nodes, right? And we're using JavaScript, so obviously these are just object literals. But if we want to link node 2 if we want to add a reference to node 2 from node 1, we could say n1 dot and add a next property and set that to n2. Okay, so if I go over here and I run node index, okay, of course you have to have Node.js installed if you're going to follow along. Whoops, I didn't console log anything. Let's console log n1. And you can see that we have data 100, which is our node 1, and then we have a next property which points to the next node, which has the data of 200. So that's kind of a very, very minimalistic, bare bones example. So let's start to create this. We're going to have a class of node, and this is going to represent each individual node. When we want to create one of these nodes, we'll go ahead and instantiate this class. And this is just going to have a constructor, and each node will take in two things. It's going to take in the data and then the pointer, which we'll call next. And this is going to be set to null by default, because remember, the last one is it references null. All right, and then in here, we're just going to take the data that's passed in and set it to the data property like that. And same with next. Okay, and I'm assuming that you have some knowledge about classes and object-oriented programming. So that's it for the node class, and we can actually construct a node. If we go n1 equals new node, and we'll pass in 100, and if we console log n1 and say node index, you'll see that we get a node object with the data 100 and next is null. So basically we just have this right here. It's just one single node. So let's now create a class called linked list. So linked list, let's have a constructor. And well, we're going to have two properties here. We're going to have the head, and that's going to be set to null by default, which means that the list is empty. If there's no head, if there's no first element or first node, then obviously the list is empty. And then let's keep track of the size of the list. So obviously that's 0 by default. All right, now the different methods that I want to create, first one is going to be to insert the first node. Then I want to insert the last node. I want to insert at an index, so basically anywhere in between. I want to be able to get from, or I'll say get at index. So basically, if I want to get, this one right here, this would be index 2. It's 0, 1, 2, just like an array. And we also want to be able to remove at index, and we want to be able to clear the list, and we want to be able to print the list data. All right, so let's start off by inserting the first node, okay? And this pertains to, it doesn't matter how many nodes we have in the list, we want to be able to insert the head, basically. So this is going to be a pretty simple method. We're going to say insert first. It's going to take in some data, and then all we have to do is set the head. So we'll say this dot head equals new node. So we're just instantiating a node object, passing in the data, and then the next value is going to be this dot head. So the reason we're putting this in here is if we want to insert the first one here, if there's already something in the head, then we want to push that to the next. Because remember, when we pass this second value in, it's this whatever next is. And if this dot head is null, meaning the list is empty, then obviously this will just be the first and only node in the list. Okay. Now I'm going to skip down to the print because I want to be able to show the actual data. Well, I guess we could just console log it for now. So let's do a const. We'll just call this LL for linked list, and we'll say new linked list, and then let's do LL dot insert first, and let's insert 100. Okay, and then we'll just do a console log here of the entire linked list. So if we run that, you can see that we get the head value is node with it's a node with the data 100. Next is null because it's the only one. So just picture just this right here. That's what we have. If we want to run this again with 200 and run node index, notice that now 200 is the first one. 200 has been inserted first. So now if you look at this diagram, 200 is here, 100 was pushed over. Okay? It was pushed over because we set next, or we set this dot head to the next value, which pushed it over. All right, so let's do a print of the list. So for this, let's say print list. Now we could print out the entire node, but I just want to print the data. So let's call this print list data. Okay, and what I'm going to do is just set a variable of current to represent the current node, and it's going to start with this dot head. And then what we want to do is loop through all the nodes. So we can do while current. And then here, let's just do a console log of current dot data, because I just want the data property. All right, and then we need to basically move along through all of the nodes. So what we can do is set current equal to whatever the next value is. Okay, so we kind of loop through it, and we're just outputting each piece of data. So let's save that, and let's just add another one here of 300, and let's see what this looks like. So if we run this, oops, I don't want to do console log. I want to do ll.print list data, and let's run that. We get 300, 200, 100. So basically, the reason 300 is first because that's the last insert first that we called. All right, now you might not want to insert first. You might want to insert last. So let's take care of that next. So this is going to be this is going to be a little more difficult than what we did here. So let's say insert last. And by the way, there's a million ways to do this stuff. This is just to kind of get the gears turning in your head. If you want to change things around, or you want to add new methods afterwards, that's good. That's good exercise for problem solving and just logic. So let's say insert last, pass in our data, and let's construct a new node. So we'll pass in data, and I'm just going to initialize here current. And first we want to take care of the edge case where it's empty, if there's nothing here. In that case, we just need to add the head, right? Because it's going to be the first and last. So let's say if empty, then make it the head. So we'll say if, and the way we can check is if it's empty is we can say if not this dot head, or if this dot head equals null, you could do that as well. Then we'll say this dot head is equal to the node. Okay, else, so basically if there's already a head, then we need to basically kind of do what we did here and loop through. So I'm gonna set current equal to this dot head because we want to start at the beginning, and then let's do while, and we want to make sure that there's a next value. So we want to say while current dot next, and down here let's set current equal to current dot next. So this will allow us to kind of traverse through the list. And then under the while loop, we're going to go ahead and add the node to the end by just saying current dot next equals node. And then let's increase the size. So I'm going to go, let's see, we want to go outside of this if statement here. And let's say this dot size, because we have a size property, and let's increment that by 1. Actually, let's do that here as well. This dot size plus plus. Okay, so now we should be able to insert onto the end. Right now, this is what our list looks like: 300, 200, 100. Let's say we want to add 400 to the end, or to the last. So we'll say ll dot insert last, and let's say 400. So now if I go ahead and I print this, notice that 400 gets put at the end. Okay, so we can now insert first, insert last. Now what I'd like to do is take care of inserts, anywhere in between. So basically add an index. And these are indexed as like arrays, 0, 1, 2, 3, 0, 1, 2, 3, and so on. So let's go right here and let's say insert at, and we want to pass in, here we're going to pass in two things: data and then the index where we want to insert. And there's a couple edge cases we have to take care of. If there's basically if we try to put an index that doesn't exist, like in this case we have our list is 0, 1, 2, 3. If we try to insert into like 20, then we want to just basically return back and not do anything. So let's say if, and you can handle this in different ways. So let's say if index is greater than 0 and the index is greater than the size, so this dot size, if it's greater than the complete size of the linked list, then I'm just going to return. Okay, we're not going to do anything. So that's one case, and we could probably put a comment here and just say if index is out of range. And there might be a couple edge cases that I miss. If I do, feel free to leave it in the comments. If you have any other ideas, I'm open to that. Just don't be a dick about it, please. The next thing we want to do is take care of if it's the first index, which is 0. So let's say, because if that's the case, then we just need to set it to the head, right? Because it's the first one. So let's say if first index. So we can just take index, and if you want to pause it at any time and try some of this stuff yourself, feel free to do it. I encourage that. So let's say if this is equal to 0, if we want to insert at the 0 index, then we're just going to take this dot head and set that to new node, pass in the data that we passed in, and say this dot head as our next value, because we're going to push that over, and then we're just going to return. Okay, so now let's see, we took care of if it's out of range, if it's the first. So let's take care of the rest. So what I'll do here is, let's say const node, we'll initialize a new node with the data, and I'm going to initialize 2 variables, current and previous. All right, and then let's go ahead and, whoops, what did I just do? Current, previous, and I'm trying to think here. Let's set current to first by saying current equals this dot head. And we're going to be doing a loop, so I'm going to have a counter. So I'm going to say let count equals 0. Okay, we're going to start that at 0. Now let's do a while loop, and let's say while the count, which starts at 0, is less than the index. Okay, so I mean, if we pass in 1 as an index, then it's going to say if 0 is greater than 1, that's going to be the first iteration. So here we want to take previous, and we want to set that equal to current. Okay, so this is basically the node before the index that we want to insert. So we want the previous, okay, because we're looking at, if we want to insert right here, which is 0, 1, 2, this is the 2 index, then we want to reference the previous one here, and we're making that equal to whatever the current is, which in this case is going to be the head. And then we're going to increase the count. So we'll just increment the count by 1, and then we're going to set the current one to whatever the next is, so current.next. So we're just basically making room for our element, or for our new node. So this is the node after the index. Okay, so outside of this while loop now, we're going to take the node that we initialized above and set the next value to its current. Okay, so the new node, or the new node next, I should say, should now be whatever the value of current. All right, and then we're going to set, I don't need a comment here, let's set the previous, we'll take the previous one, which would be, if we were inserting here, would be 200, and let's say dot next, which would be this one here, and that's where we want to insert the new node, so we're going to set that equal to node. Okay, I know that's probably confusing, especially if you're kind of new to JavaScript and all this stuff, but this should work. And then we just want to increase the size because we added a node, and let's save, and now we can test it out. So let's see, we have 300, 200, 100, 400. Let's say we want to put 500 at the 0, 1, to index, so it should be in between 200 and 100. So I'm going to say ll.insert at, so we need the data, which is going to be 500, and we want to put that at the to index. So let's run that, and now you can see that we have 0, 1, 2. So 500 is at the to index. Now let's try some other edge cases, like if it's the first one, let's make sure that works. So now if we run that, 500 is now the head, it's now the first one, which is this this case right here. Let's test this out where if it's out of range. So if I try to put it in the index of, let's say 10, which doesn't exist, and we run this, it's just not there. Okay, it just doesn't get added. And if you want to change the logic around, maybe you'll want to add it to the end. You can do that. There's no set in stone rule on how that works, as long as you follow the basic principles of the linked list. Okay, so now that we can insert wherever we want, let's what do we have next? Get at index. So basically we want to be able to get a value at a certain index. So let's say get at and pass in an index. And some of this is going to be pretty similar to what we just did. So we're going to set a current variable to the beginning, which is this dot head. And let's set a count to 0. And then we're going to just loop through this. We're going to say while current. Then we want to test to see if the count, which is initialized with 0, is equal to the index. That's how we're going to tell which one we need. If it is, then let's do a console log of current. That'll give us the whole node, but let's just get the data. All right, and then down here, let's see. Under the if statement, we need to increment. So let's say count plus plus. And then, of course, we need to move along the linked list down the chain. So we're going to say current equals current.next. Okay, otherwise it'll just be a never-ending loop. And then down at the bottom here, under the while loop, that means it's empty, so we can return. We'll just return, I guess. Yeah, it should be fine. Or return null. Okay, so let's save that. Now I want to be able to get a specific value from an index. So let's go down here and let's say, instead of print list data, I'm going to comment that out. Let's do ll.get at, and let's see what's at index 2. Okay, we'll clear this up and run it. That didn't work. Why didn't that work? Looks like I have extra. Wait a minute. While current, if I did a single equals. Okay. So let's try that again, and we get 100. So is that correct? So that's index 2. So 0, 1, 2 is 100. Let's try get at 0. We should get 300. Let's try get at 10, which doesn't exist, and we get nothing. Okay, and again, if you want to change the logic to get the last value or whatever, you can do that. All right, so now we want to be able to remove at a certain index. So let's say remove at, pass in an index, and I'm going to first check to make sure the index, or we'll say if the index is greater than 0 and the index is the index is greater than this dot size. So basically if it's out of range, then let's just return. Okay, and then we're going to set our marker, or our current variable, to the first node. And then let's initialize previous, and let's initialize count as 0. Okay, so if it's the first, let's say remove first. So if, whoops, if the index is equal to 0, meaning we want to remove the first one, then that's pretty simple. We can just set this dot head to current dot next. So basically we're just setting the head to whatever the next value is. So it would make 200 the first one. All right, else, so if index is not equal to 0, then let's do a while loop. And let's say while the count is less than the index, then let's increase the count. And we're going to set that previous value to the current value. And we're going to set current to whatever the next value is. So current.next. Okay, and then to remove the element, we'll go outside of the while loop and we'll set the previous dot next value to the current dot next value. All right, and since we removed, then we want to decrease the size. So underneath the if statement, let's say this dot size minus minus. Okay, so let's clear this up and then let's try to remove. So right now, let's print this out. Okay, so we have 300, 200, 100, 400. Let's say we want to remove 100, which is in the 0, 1, 2 index. So right above the print list, let's say ll dot remove, remove at, and we want the 2 index. So now let's run this, and now 100 is gone, which is the 2 index. Let's try to remove the 0 index, which would be the 300. So if we run that, now 300's gone. If we want to remove the last one, which is 0, 1, 2, 3, so if we remove the 3rd index, that should get rid of 400. And then if we go out of range, we'll say 33, then it just gives us, it doesn't remove anything. Okay, so now we can print the list, we can insert at the beginning, at the end, in the middle, we can get values. Last thing I want to do is to be able to clear the list. So let's say clear list, and this is pretty simple. Now remember, the class here, it only knows about the head. So if we set this dot head equal to null, then that should clear everything out, because now we have no reference to the rest of the list. And then we'll just set the size also equal to 0. All right, so if I go down here now, right between the inserts and then the print list data, and I say ll dot clear list, and I run this, we get nothing. Okay, and it might be still stuff stored in memory, but that's besides the point. We just need to have a working linked list. All right, so it's kind of just a good exercise to work out your mind. So if you guys want to continue on, maybe create a remove last or remove first. You could do that, or get first, get last. There's different methods you could add to this to kind of work on your problem solving skills. But what we have here is adhering to the principles of a linked list. And I know that some of it might not be completely clear. I know it can be kind of difficult, but there's a lot of information out there on linked lists in all types of languages. So that's it. Hopefully you guys enjoyed this. If you want more content like this, where we do just logic and problem solving and stuff like that, let me know. Of course, we're going to still stick to projects and stuff like that. But I'd like to get more into this stuff, and you can give me some suggestions. All right, thanks for watching, and I'll see you next time.